Greetings. I'm Dr. Jason Ozuko of the Psychology Department at SUNY Geneseo, and these are my top 5 PsychoPy programming tips. Number 1, name your routines and variables and comment your code. Look, when you don't take the time to actually name any of the routines or components or variables that you're using, things can get confusing really quick. And sometimes I know you think, I'm just going to throw this together, and who cares if I've identified which screens are the instruction screens and which trial I'm talking about. I know which trial corresponds to what in my experiment. However, honestly, you're probably not going to have as clear a memory of all this stuff 6 months or 1 year from after you've programmed an experiment, and it's very common to have to look at data that far in the future. And nothing is more annoying than coming back to an experiment that you made and being confused about what text_2 is actually showing or what trial _2 actually means. So when you are making experiments, take time to label things. It doesn't take very much time to add proper labels to all of your routines and components, and it makes a big difference. I mean, look at this. We can now actually read the labels of this experiment and know what the different components are without actually knowing really what's in this experiment. And by the way, this extends to your code. Make sure you comment your code. Code can get very complex very quickly, and honestly, it helps to be overzealous with the number of comments that you actually include in your code. Remember, you can never comment your code too much. 6 months or a year from now, when you go back to look at your code, again, you might understand your code today, but are you going to understand it in the future? Commenting your code is just a very helpful way of making it abundantly clear what your code is doing. And since we're on the topic of your code, one little bonus tip is you're not programming an operating system here. You don't have to have the most efficient code in the world. So rather than, for instance, having a single line of incredibly complex code, break that up into less efficient but easier to read subcomponents and comment those subcomponents. Having things be simpler and easier to understand is always better than having things be super elegant yet difficult to understand. Because when you want to update your experiment down the line, it's a lot easier to update if it's easy to read code than if it's hyper efficient code that's going to save fractions of milliseconds. Again, your experiments are not operating systems. They don't have to be the most efficient things in the world. They just have to work to the point where you're collecting data from subjects. So don't get carried away with making your code too efficient. Readable is always better than hyper efficient. Number 2, reuse your routines. Look, don't build the same routine twice. You may not have known this, but you can actually take one routine that you've created in PsychoPy and insert it multiple times into your timeline. Now, because you can do this, it's not only a waste of time, but it's bad practice to make multiple routines that do essentially the same thing. For instance, in this dummy experiment, we have a practice trial and an actual stimulus trial. Now, in this case, I've actually created a separate routine for my trial and my practice trial. And let's imagine that they're virtually identical. They just show a stimulus, and that's pretty much it. And there's a bit of timing going on with when the stimulus and perhaps a context is presented. Now, if I spent the time to create 2 versions of the same routine, you could say, well, there's nothing really wrong with that. And you'd be right. My experiment might work. But let's say I decide to make a change to perhaps the timing or the stimulus or the response or something about the trial. I now have to go in and make the change in both the practice trial and the actual trial. And if I mess up and I don't put the exact same parameters in practice and the actual trial, then my experiment, the practice trials, will be out of sync with the actual trials. So when you create the same routine more than once, you're actually not just wasting your time, but you're opening yourself to errors and mistakes. So rather than having a separate practice trial and actual trial, what would be better is to simply have a trial and everything that I want in the practice trials and the actual trials is identical. Now, if I make changes to the practice trials or the actual trials, the changes occur in both loops and my 2 phases stay in perfect sync. And you may be wondering, well, how do you deal with the fact that maybe in the practice trials you want something like feedback? So maybe in the practice trials, you're going to show more to the subjects than you would in the actual trials. And this is where the second component of this tip comes in, which is break up your trials. Don't have them all contained necessarily in one routine. So for instance, blank periods, I would encourage you to never include those as a coded component of a routine. Notice here that my trial doesn't start until about 500 milliseconds, until exactly 500 milliseconds in. Why did I code this into the trial itself when instead I could have created a new routine called blank 500 for blank for 500 milliseconds and included an empty text object for half a second. Now, if I do this, this blank 500 routine can be inserted wherever I want. And so I can control where in the experiment there are going to be 500 millisecond gaps. One of the reasons that this is advantageous is if you ever want to change the gap between trials, you can now change it in one spot. And I could go in here and change this to, let's say, 250 milliseconds. And I'm going to, of course, rename my object. Remember to name things, spend the time to name things properly. And now I can quickly see that all of these times have changed. So by pulling out a blank period from part of a trial, you can more easily see in your timeline what the timings of things are. And you can also add in routines that you are not going to have in all parts of the experiment. So rather than having a practice trial object where you set up maybe a feedback after the response and then have a trial routine where you don't have feedback, but they're essentially the same routine, just make the trial routine stand by itself and then have a separate routine where you show the feedback and insert that routine only in the practice loop. Now you can see we've added in a blank period, we have our trial, we can add feedback only to the practice loop, and we don't have to have two separate trials. We still have one routine that's going to show our trial in the trials loop and the practice loop. And if we ever update things, anything we do for our trials will occur also for our actual practice trials as well. So everything will stay in sync. So reuse your routines. It's very flexible to do this. And break up blank periods out of your trials. Don't try to overload a trial and, again, get really fancy with everything. So if we go back and look at our practice trial here, rather than having a 500 millisecond blank, have that be a separate routine. It'll be a lot easier if you ever decide to change things. Because as it is right now, if I do decide rather than 500 milliseconds, I want to have 250 milliseconds, I have to change the timing of the context item, the stimulus, and the trial response. It's a lot of changes to make to change one time, as opposed to here, I can change this one object, and now timing for the entire experiment has changed. Here's another little bonus tip. If you have included multiple components and you want to move them around, you easily can by right-clicking on them and selecting move up and move down. And, as I've already said, it's good practice to name your routines and variables, comment your code, and organize things properly. So it just takes a little moment to move things into a sensible order. But you might want to organize, for instance, items on a trial in terms of the sequence with which they appear or in terms of the sequence of importance or something like that. So you can organize things here too to stay organized. Number 3, avoid hard-coding numbers and ranges whenever you can. So it's very tempting, I know, when you're making an experiment to input the number of trials you want to have in, say, a practice phase or a study phase or a test phase or something like that. However, this is another area where doing so makes your experiment less flexible and more open to errors if you ever decide to change things. Rather than putting in hard numbers, it's often better to include a variable that you specify at some earlier startup point of your experiment. For instance, in this experiment, rather than hard coding in 40 study trials, we can rely on a variable called number of study trials. Earlier in your experiment, you can have some sort of startup code where you specify some basic parameters that you want to use. The usefulness of doing this is that if you decide you want to change the number of study trials, let's say, you can simply find that startup variable and change the number. And if in the rest of your code, rather than referring to 40 study trials, you instead always refer to the variable numStudy, then what you will find is that your code will adapt to the number of trials that you actually want to use. So again, this is similar to the previous recommendation of reusing your routines, but rather than having sprinkled throughout your code reference to the number 40, you could just have one variable that's specified once that contains the value 40, and then throughout your experiment, whenever you need to reference the number of study trials, you use the variable numStudy rather than 40. So if tomorrow you decide you actually want 60 stimuli, you simply have to change this variable when it's initialized at the beginning of the experiment, and then all references to that variable will change. This means that it's a lot harder to make errors. Imagine if instead we'd hard-coded that 40 at multiple points in our experiment as we're writing code to refer to our number of study items. If later we switch to 60 items, we have to track down every instance of that 40. And if we miss one, then our experiment is going to have an error. So don't hard code numbers whenever you can. Instead, try to reference variables, try to use code that references variables rather than a hard number, and instantiate those variables once if you can. And there are multiple ways also, by the way, to have startup parameters. One thing I like to do is have a script object at the very beginning in its own routine where I can specify some startup parameters which executes at the beginning of the experiment. Another thing you can actually do is if you have two versions of the same experiment, let's say you want to run condition A and condition B, and you want to have a slight variation in those conditions. Well, one thing you could do is you could have your code randomly select a number from 0 to 1, and if it's 0.5 or less, then your code arranges things so that it's condition A, and if it's 0.5 or more, it arranges things so that it's condition B. And here's an example of some code that is setting up two different conditions in the same experiment. So is double study false? Is double study true? Now this setup is actually coming from user input. So here we didn't select a random number. What we did is we actually had a routine that the research assistants were going to respond to. And in this routine, we said, should this be a single or a double or a control condition? And researchers could press S, D, or C, and we captured that with a keyboard response. And then the code started up, and it checked to see which key was pressed. Was it an S? Was it a C? Or else it is assumed to be a D. And here what we did is we changed some of the key parameters that would need to change in the different conditions. So this is almost yet another instance of reusing your routines. We're now reusing the same experiment to run 3 different conditions, depending on does the research assistant press S, D, or C when the experiment starts up. Now, why is this preferable over having maybe 3 versions of prod double? We could have had prod double S, prod double D, prod double C, and have 3 separate files. Well, again, we would have to make sure that all of these routines and timings and everything was identical between our 3 conditions to make sure our experiment was running properly. Now, of course, you can do that. You can build the entire experiment once, save it, and then save as another version, and then change the few parameters you need for the next condition and do the same for the third condition. However, if you ever decide to make changes to timing or anything like that, you've now got to go into 3 separate PsychoPy files and make sure they're identical. The better way to do it is to have startup parameters, and again, to not hard code things as much as you can. So by giving the research assistants an opportunity on an opening screen to press a keyboard response and then parsing that and changing the few variables that need to change between our conditions, we can now have one script that runs 3 different conditions flexibly. And if we ever change how long a study trial lasts for all 3 of our conditions, that change will occur. So avoid hard coding numbers and ranges. This makes your code more flexible, and consider having startup parameters if you can. And this will allow you a lot of flexibility, especially if you're running multiple versions of the same experiment for your different conditions. Number 4, verify you're logging what you need before you start data collection. This one might seem a little self-evident, but it's always really good practice to make sure that your experiment is logging everything that you're going to need before you actually start running it for real. Now, I bring this up in a PsychoPy tutorial video because there are a couple of tricks you can use to help quickly verify that your stimuli are being generated correctly and that you're collecting all the data that you need. So when you open up any data file in Excel, there's a couple of tricks you can use to actually quickly tally things up. For instance, let's say here that I was concerned about the number of yellow and blue trials that were being presented in my study phase and the number of allowed and silent responses. What I'm going to do is just copy these columns to a separate sheet to make things a little cleaner. But you should be very familiar in Excel with the data sorting functions. So if you click this sort function, you get an option to sort by columns. And I'm going to say that my data has headers because the first row are labels. And if I do that, I get the option to sort by type or color. So for instance, if I sort by color, now I can look at all the blue trials and all the yellow trials. And lo and behold, I can quickly highlight all the blue trials and see that I have 40. Shows me a 40 when I highlight them all. 40. Blue trials, and when I highlight all the yellow trials, I also have 40. You can see right there. Now, this allowed me to very quickly check the number of trials that I have in my study phase, and if I'm expecting 40 blue and 40 yellow, I know my code has executed things correctly. So in Excel, you can, using the data sorting functions, very quickly tally up how many different items of different categories you have. You should get very familiar with the data sorting in Excel. I mean, you can also sort things hierarchically. So here's another set of data where we had a study and a test phase. And if I want to keep the study trials away from the test trials, as they are sort of by default here, one thing you can do is first sort by phase, and that will have the study trials sorted before the test. And then you can add another layer. And what this will do is now within the study trials, sort by another column, and within the test trials, sort by another column. So we can sort by color. So by adding a hierarchical sorting, first starting with phase to keep study and test separate, and then by color, you can first look at all the study trials that were blue, and you can get a tally of how many there actually were. In this case, there were a lot. And you can see how many were yellow. And then you can do the same thing for the test phase. So Excel allows you to very quickly analyze your data files and to get count of all the different kinds of stimuli you have. So that's one thing I definitely recommend everyone do after you've coded an experiment. Make sure you have the right number of trials. The second thing you should do is try analyzing one subject start to finish. Now, you might have to actually wait until you run your experiment to do this, but it's good practice to get in, because if you've forgotten a variable that you're going to need, it's happened to me even, where you think you've coded a really nice, elegant experiment, and you're collecting all the parameters that you're going to need, and then lo and behold, you go to analyze your data and you realize that there's a missing column of something that you should have included. So after those first couple subjects come in, go ahead and analyze them and just make sure that you're getting everything that you need before you let the research assistants carry on and collect more data. And one more little bonus tip since we're at it. Remember how I told you to reuse your routines? Well, this also is a very efficient way of, if you have to go in and run your experiment and get that first data sheet in order to count up all your stimulus trials and make sure you have the right number of stimuli. If you've reused your routines, it's really easy to do that. Because let's say that you have an experiment with like 500 trials and you don't want to sit through all the trials yourself because you're a busy person, you got things to do. But you still want your experiment to run once, start to finish, so you can go and look at all the trials it generates. Well, one thing you can do is go in and for all the blank periods, rather than have them be 500 milliseconds, just change them to a fraction of that. Do the same thing with the timings of your study trials. And, if you've practiced in actual trials and you've reused the routine, once you change the timing of those trials, it will automatically change the timing of, the practice trials and so on. And so bump all the timings down to something really low, run your experiment. It will go by in about 5 seconds and you'll get a data file out of that. And of course, the reaction times and everything are useless, but you'll get a nice big list of all the stimuli that your experiment arranged and showed, and you'll be able to tally up and see, do I have the right number of new _A trials? Do I have the right number of new _B trials and allowed trials, and so on? And again, you can use the sorting functions to quickly arrange items and then highlight them to see, do I have, in this case, 40 allowed trials? Do I have, in this case, I think we also want 40 new A trials, and so on. Number 5, you can edit your psych experiment and Python files that are generated from your psych experiment file in a text editor. So did you know that your psych experiment file is actually just an XML file? If you load this up in a text editor, you will see all the different components that you actually set up in your experiment are presented here in relatively easy to read and easy to understand code. If you're familiar with HTML markup language, then you're probably somewhat familiar with the concept of XML. So you can see here we have a text component called welcome screen, and there's information about the color, its color space, various things about its font, its orientation, and even the text that is going to be shown on this screen. Now you may wonder, why would I ever want to open up my psych experiment file with the text editor? And the answer is that sometimes it's actually easier to edit things in here than in PsychoPy. For instance, let's say that you actually wanted to create a row of text objects in a routine. Well, you could come in here and repeatedly click on the text object, setting up the timing duration to be what you need, erasing the default text, entering what you want, editing the position so that each subsequent text object appeared further along in this row, and mess with any other parameters that you need. However, because you're setting things up in a row, it may be the case that 90% of the parameters for each of the text objects you want to add are identical, and you just really need to change the X position and maybe change what the text is that's in the object. But everything else should be the same. Well, if you simply insert a text object in PsychoPy, you're stuck with the default parameters it gives you. However, if you go down into the actual code itself, you can highlight a text component, copy it, and then you can paste it, and now you have a duplicate of it. Be sure to rename it so that you don't have two objects of the same name, but all the parameters are now identical, and you can look for the position, and you can go ahead and change the position variable slightly, and now you have an exact copy of your previous object, only in a slightly different position. So coming in and messing with the raw PsychoPy experiment file can actually be very useful when you're trying to do complex things, and you don't want to be clicking through the PsychoPy menus repeatedly, because you can simply copy and paste things here, change a few numbers, and it's a lot faster, to be honest. Now, I will preface this tip and say that if you are going to monkey with the PsychoPy experiment file, be sure that you've backed this up, because if, for instance, you mess up your file by leaving a tag open or, mistyping something, PsychoPy might just refuse to open your experiment and might crash, and you might have bricked your experiment. So be sure that when you do decide to edit this stuff, you have a backup from before you started editing, just in case you happen to screw something up. And similarly, every time you run a PsychoPy experiment, a Python file is actually generated. And this is the actual code that PsychoPy runs to run your experiment. So all of this stuff here and the code, the XML code that it's based on, is basically just instructions for how PsychoPy should end up constructing your Python file. But here's the real code that runs your experiment. Now, 99% of the time, you're never going to need to look at this code yourself. But if you're ever trying to do something advanced in PsychoPy and you can't quite figure out how to do it, or you know that there's something that PsychoPy is doing and you want to do that too, but you can't quite figure it out, I mean, I have found it helpful at times learning how PsychoPy works to open up these Python files and try to find the part of PsychoPy that I'm trying to replicate or emulate or change and see how the code actually executes in Python. So as a very simple example, if you didn't know how to manually add variables to the data file, by doing a bit of searching around in the Python file, you would eventually stumble upon this experiment.addData and see that that's actually how PsychoPy is logging data to its experiment files. And you could then use that knowledge to manually save your own variables to the PsychoPy data file. Another thing you could learn by looking at these Python files is that if you want to actually quit a routine, you just need to mess with this flag called continue routine. Continue routine is checked throughout PsychoPy's experiments to check to see if it should end a current routine. And so when you're designing your own script in your own experiments, if you need a routine to end early, you can just flip this Boolean variable and you can manually force a routine to end. So those are just some of the things you can learn by poking around in an actual Python file that's generated from PsychoPy. Again, 99% of the time, you won't need to look at this, but know that it's here and know that if you are encountering something that's getting you stuck and you think the solution might be in PsychoPy's code, you can come and look at what PsychoPy is actually doing, and you can try to learn from PsychoPy's code how to mess with PsychoPy in a slightly advanced way. So those are my top 5 PsychoPy programming tips, but what are yours? I'm sure you have little ingenious tips of your own that you use to make your experiments more efficient and more flexible and more effective. Feel free to share your tips down below or comment on the ones that I've shared here today. And whether you've got your own tips or not, I hope these tips help you become a better PsychoPy programmer. Don't forget to subscribe, and thanks for watching.